In today's video, we will answer the question, how do we use proportions to calculate the size of a scale model? Scale and similar figures are used to represent objects that are too large or too small to build to actual size. So things like this would be toys, model cars, model trains, Lego models where you want to build the Eiffel Tower, but you can't actually build the Eiffel Tower. So the scale gives the ratio that compares the measurements of the drawing or model to the real objects. And so remember, two ratios together is going to be a proportion. So the measurements on a drawing or model are proportional to the measurements on the actual model. So to solve scale and similar figure problems, we will be setting up a proportion. For our first example, we have this train. And the problem says determine how many inches the scale model would be. So this is the real train. It's 60 feet long. But they give us this scale, which is 1 inch equals 8 feet. So here's how we want to set it up. I want to make sure that I label that I have my model and my actual so that I can line this up. So the scale is telling me that 1 inch on the model is equivalent to 8 feet on the actual model. So the other piece of information that I have been given at this point is that the actual train is 60 feet. So I'm going to go ahead and write 60 feet over here because I've labeled this actual. And now the only blank that I don't have is this, and so I'm going to put an X. So now we're going to go ahead and solve the proportion by using cross multiplication or butterflying. And we're going to get 1 times 60 is 60, and 8 times x is 8x. This is a one-step multiplication problem. I'm going to divide both sides by 8 to get x by itself. So now I have 60 divided by 8. And I have 7 because that's going to give me 56. Add a decimal because I ran out of numbers. And my answer here is going to be 7.5 inches. And that is the answer to this problem. Skipping ahead to number 3, it says the scale on a set of architectural drawings for a house is 1/2 inch equals 1.5 feet. Determine the length of each part of the house. So they give us 4 different rooms, and they give us the drawing length, which is the length on the piece of paper. But of course, if I didn't have scale, I would have to have a house-sized piece of paper. So they've given us the scale of 1/2 inch equals 1.5 feet. And that's going to be important. Now, I don't want to deal with fractions right now, so I am going to make this 0.5 inches and 1.5 feet because 1/2 turns quite nicely into 0.5. So let's go ahead and set this up. On 1/2, we're going to have a drawing. And on the other half, we're going to have the actual size of the house. And so it says that I have 0.5 inches for every 1.5 feet. And it's important to note that this scale is going to be used for every single one of these rooms. We are just going to swap the numbers out as we go. And I'm only going to do 2 of these for sake of time. So let's start with the living room. We already know that we're going to have 0.5 inches and 1.5 feet. And it says that the living room is 5 inches. So remember, the drawing was on top. So this is going on top. And an X is going here because I don't know what the actual length is. That's what I'm solving for. And now we are ready to butterfly. So we're just going to go 0.5 times X is 0.5X. And then we have 1.5 times 5. So I need to figure that out. Got 1 decimal. It looks like my answer is 7.5. This is a one-step multiplication algebra problem. So I want to divide by my number that is next to X, which is 0.5. Remember, the division rule says that I cannot divide by a decimal, so we're going to move this decimal 1 place over to make it the whole number 5, but that means that this one also needs to get moved over, so my decimal point is right there. So 5 goes into 7 once, and 5 goes into 25 5 times. So it means the actual length of the living room is 15 feet long. Let's do one more on this table. Let's go ahead and do the kitchen. Now it says 5.5 inches. I would like to make that 5.5. And remember, this is the drawing, and my drawing is on the top. So you want to make sure things line up. So we're going to put 5.5 inches here and an X because we don't know that answer. So we can start butterflying again. We're going to get 0.5X. And now here it gets a little more interesting because now we have 5.5 times 1.5. So I'm going to do that over in this corner. So remember, with the decimals, we treat this just like a 2 by 2 multiplication problem. So I'm going to go 5 times 5 is 25. Again, 5 times 5 is 25 plus 2 is 27. We're going to put a 0. We're going to skip the first one. We're going to go to the 1. So 5 times 1 is 5. And 5 times 1 is 5. And then we are going to add, and we're going to get 5, 12, carry the 1, 8, and there's 2 decimal places, so this is going to be 8.25. So remember to divide by the number that is next to X. So we're going to divide by 0.5. Remember, again, the rule, I can't divide by a decimal. I got to move 1 place, which means this moves 1 place, and I'll put it up here for reference. So it's going to be 132 is 6. It's going to leave 225. So my answer is 16.5 feet. So you would do the dining room and the basement the same way. It's just that this number right here will change to 4 and 10, depending on what room you are doing. So to review, in order to solve a scale model problem, you will need to know your model or drawing, and you will need to know the actual. Your first fraction will be your scale. like 1 inch equals 3 feet. And your second one will be the actual size. So maybe on your map it's 4 inches and you wanted to know this. Or they told you that your actual was 60 feet and you want to know the size. So be sure to read carefully, look for your scale, and make sure that you label things when you set them up.